Okay, this is the lesson for GCO4, details of transformations. So if you want to just put a line on your paper from the last lesson, if you have not watched the last lesson, then that's all we wrote on it. But you'll want to do that. So GCO4, details of transformation. Here is an example of a detail of a transformation. So we have this clock, right? And if I were to move this minute hand, so how many degrees basically is asking details of the transformation. So if I moved the minute hand that far, so from the 6 to the 2, how many degrees did I move it? 180? No, so 180 would go all the way up to the top, right?
It's a third of 360.
So this all the way around is 360, right?
What's a third of 360?
So 360 divided by 3? 120, yeah. So if this is one way of doing it, is you can say, I know that there are 12 on a clock. It's convenient because I labeled it with a 12. There are 12 sides, so I could take 360 and divide it by 12. So I could take my calculator and I could do 360 divided by 12. And that's 30. And then I moved 1, 2, 3, 4 of those. So then I times it by 4. And I got 120 degrees. So that's one of the things that you're going to have to do. Another thing that you're going to have to do, and I'm just going to show you with this. Are you guys okay? Can you see that rectangle okay with the paper? Yep. They're both being white. You're okay with that? Okay, so if I were to take this and translate it like that. Actually, do you guys see? Let's look at this corner right here. And if I translated it to right here. So right now it's right here. And then I translate the whole thing to right there. How would I describe that translation?
2 down.
So it's 2 down and then over 5, right? So then the translation in coordinate notation, you guys remember coordinate notation, would be so we would go right 5. If you want to do a plus in front of the 5, you can. And then down 2. But if I wanted to know, like, what was that distance? And I'm going to do a dotted line in between. Like, if I went from there to there and I wanted to know that actual distance from there to there, what do you think you might use to find it? Do you guys remember that? Good, Pythagorean theorem. So we would use the 2, and we would use the 5, and we would use the Pythagorean theorem. So to get an exact answer, which Alex will ask you for the exact answer, then I would do the square root of 2 squared plus 5 squared. So what is 2 squared?
2 4.
What is 5 squared? So it's still, so the exact answer would be the square root of 29. It'll say no decimal approximation, so you just leave it like square root of 29. That's it. So it'll ask for all those lengths. And if I moved one corner, of my figure, that square root of 29, and it was an honest to goodness translation, all of them would move that distance. So like, let's call this one A, and once I moved it, it would be A prime. Do you guys remember doing A prime when you move things? So that would mean that A, from A to A prime, would be the square root of 29. And then no matter what the other points were, they should be the same. B to B prime should also be the square root of 29. All of them would be square root of 29. Does that make sense?
Yes.
Okay. So we'd have a direction that we move, and we'd have the distance that we move. Okay, next thing. So this was for translations. Translations. This was coordinate notation. Coordinate. Let me do notation. Coordinate notation. Okay, you writing this down? Am I going too fast? I tried to keep it basic and simple. Too fast? Okay. The good news is if it is too fast, you can always go back and watch it again later. Okay, the next detail is you'll have to know details of reflections. And it will tell you things to like, it'll say take a triangle. So I'm gonna make a little baby graph. And if you don't have graph paper, just do your best. I'm not gonna make it like super detailed. And let's just say that we have a triangle that's a really simple triangle. So let's say we have one point A is at 1, 1. And B will be at 3, 1. And let's just have C at 2, 2. So we have this triangle. And then it'll tell you something like, reflect that triangle across, so it'll say like across, and let's do an example of this if x equals -1. So on my x-axis, this right here is, on my x-axis, this is -1. So how I graph the line x equals -1 is it would be a vertical line like this. And then there's these cool things that it follows. You guys need some time writing those graphs down, drawing the graph. Okay, you got it? Or do you need more time? If you need more time, say need more time. You good?
I need more time.
Okay. Okay, so this is for the reflection stuff. And again, it'll say like reflect it, whatever, across a line. So if it's across a line x, so this is the line right here. This line is x equals -1. So that's the line x equals -1. So right now, how far is it from the line of reflection to A? How far is that? 2. So that means my A prime is going to be 2 in the other direction. So that means that this is A prime. Does that make sense? How far away is C right now from that line?
Trace.
3. So we're going to go back 3. 1, 2, 3. So that's going to be my C prime. And then B, this is another thing that you can do. You can do all the way from the line of reflection, but I can see that B is 2 away from A. So 2 away from A. So that's B prime. Okay. Does that make sense? Okay. And then how are these? So like if I connected all these lines here with the image and the pre-image, because this is called the image and this is called the pre-image. And this one's the image. And sometimes they use those words and sometimes they don't. But so how would you describe these lines, like those connections versus the line that we reflected across? Like how are they related? How is this line related to that line? Is it parallel? Is it like, what is it? They're perpendicular. Good. So I would say, no, I'll just write for the one on top. C, segment C to C prime, and I can show it's a segment by putting a line on top, is, and are you guys ready for a really cool symbol for perpendicular? Perpendicular symbol is an upside down T, and then you don't have to write out the entire word. So is perpendicular to X.
Upside down what?
A T, like an upside down capital T.
That looks like a B.
Okay, and then there's a box in the corner.
Oh, okay.
X equals -1. So the line is like an upside down capital T with a little box in the corner. Yep. So they're perpendicular. So that's perpendicular in all of them. Would you agree that like A and A prime and B prime, those are all perpendicular? And so I'll just go like this, dot, 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 dot. Okay. You could keep on going. And then all these distances stay the same. Like whatever that distance was from A to C is the same thing as A prime to C prime. This was 2, so this right here is 2. Technically, that's the square root of 2, and that's the square root of 2.
Would A and B be switched on the left side?
No, because see how this is the line of reflection, and if I literally took the paper and like folded it over, see the A's would line up. Do you see what I'm saying?
Wait, so why are you doing the 2 thing?
The 2 thing. The distance from A to B was 2, and even after I reflected it, the distance from A prime to B prime was
No, but
still
I mean
2.
like the square root.
Oh, if I did the Pythagorean, that's a good question. If I did the Pythagorean theorem with 1 and 1, then I'd have the square root of, 1, that's supposed to be 1 squared plus 1 squared, which is just the square root of 1 plus 1, which is the square root of 2. So that distance from here to here is the square root of 2.
Alright,
Main thing I was saying there is that those distances stay the same.
alright.
Okay, and then, all right, next detail that you need to know is rotations. Rotations. And so I will give a hint. I would use paper, the corner of papers, corner of your paper, of some paper, to be able to help you decide if it was 90 degrees. And do you guys remember clockwise and counterclockwise?
Yeah.
So we have turning to the right. So clockwise. Clockwise means that you would turn right. And then counterclockwise, and I'm just going to do counter C, is turn. That's supposed to be the word turn. Left. So that's supposed to be an R. Turn right and turn left. So go the other way around this way.
Don't write down stuff that like I clearly already know.
I'm trying to write it really small, so even if you do write it down, it's not like you're like making your hand cramp, right?
No, it's like, just because I'm writing it.
So, let's see. So it will say like rotating, so it'll rotate some figure, and then it wants you to know the angles of them. So let me see. I don't want to draw pictures of this. So just remember that 90 degrees would be the corner of the paper. That's probably going to be the best thing. Do you guys remember how angles go? Like if I have angle A, B, C, where is, so, and then I drew that angle, where would A and B and C go?
A would be in the top.
Okay,
B
so
would
A,
be corner,
mm-hmm.
and then C would be the end.
And the main thing that you have to know is that B is in the corner because B is the vertex of
So
the
it's like
angle.
the way that you'd read comic.
Yep. So just remember that that's how angles go. The middle one is where the center, like that vertex is supposed to be. So you go from one to this one to that one. Okay. And, yep. You're going to have to know that Pythagorean theorem again really well. So that's probably the hardest thing is the Pythagorean theorem and getting exact things. Do you guys need any practice on finding using the Pythagorean theorem? Like, I think we gave a pretty good example here. Okay, that's the end of 6.4. Basically, this is the formula, the distance formula, and if you're going to type it in your calculator, you'll need the parentheses around it. But what this is saying is that x2 minus x1, that's how far apart the x's are, so you can really just put that in for the a up here in the normal Pythagorean theorem thing. And then y2 minus y1 is how far the y's are apart, and you can put that in place of the b. Does that make more sense? Okay, I just like drawing it on the graph and then counting the boxes instead of having to do like, then you subtract this, and you know, like it just looks really confusing to me. Okay, there you go.